its lower fixed point, or the ice point, is 0 degrees Celsius, and then the steam point or the upper fixed point is also 100 degrees Celsius. In between, it is divided into 10 equal parts. And for this reason, the Celsius scale is also termed as a centigrade scale. So it's ice point 0 degrees Celsius, its steam point 100 degrees Celsius. So steam point, which is also known as a upper fixed point, and then the ice point, the lower fixed point, and is divided into 100 equal divisions. Then the Fahrenheit scale, we have its ice point as 32 degrees Fahrenheit, and then the steam point is 212. And these are values you must know by heart. Please. These are values. Hello. Please mute yourself if you just joined, okay? Then the Kelvin scale or the absolute temperature scale, we have the ice point or the lower fixed point as 273, an approximated value of 273 K, and then 373 K. Then there is a third point for which this is known as the triple point scale, which is the 0K. Which is the 0K. And this is because the Kelvin, this is why the Kelvin scale is also known as the triple point scale. Why 0K? The 0 Kelvin scale is there because, you see, we can increase temperature to any limit. The temperature of a body can be increased to any limit, okay? But we cannot lower the temperature of a body to any value. It has a limit where the temperature of a body can be reduced to. And this limit where temperature of a body can be reduced to is the 0K. So when a body's temperature is dropped and at 0K, there is a almost zero average kinetic energy of the molecules of that substance. Please, temperature of a body is the measure of the average kinetic energy of molecules of a substance. Please write that down. The temperature of a body is the measure of the average kinetic energy. Okay, average kinetic energy of the temperature of a body. Okay, the temperature of a body is the measure of the average kinetic energy of the molecules of a substance. Is a measure of the average kinetic energy of the molecules of a substance. So what it basically means is that when we talk about temperature, we are looking at the kinetic energy, the average kinetic energy of the molecules of a substance. When the average kinetic energy of molecules increases, their temperature would also increase. And when it decreases, temperature would also decrease. So absolute temperature we say is directly proportional to the average.
What's wrong these people are?
Anderson, please mute yourself. Anderson. Average kinetic energy of molecules of a substance. Okay. And when two quantities are said to be directly proportional, note that an increase in one also causes an increase in the other. A decrease in one also would result in a decrease in the other. So absolute temperature is directly proportional to the average kinetic energy of molecules. Okay, so if we cool off a substance, I said we can increase temperature of a body to any, okay, value. Okay, increasing temperature has no limit, but you can decrease temperature of a body, okay, to a limit, meaning decreasing temperature has a limit, and the limit to which a body's temperature can be decreased is the 0K. When a body's temperature gets to 0K, we have zero kinetic energy of the molecules. Zero kinetic energy of the molecules. So if zero kinetic energy, then it means that at this temperature, we cannot record, at this particular value of 0K, we cannot record temperature because there is no kinetic energy of the molecules. Please note that the emphasis is on the kinetic energy of the molecules. Okay, we are looking at the kinetic energy of molecules and also disregarding the kinetic energy of the whole object or substance as a whole. So we are only interested in the kinetic energy of the molecules of the substance, where we disregard the kinetic energy of the whole object or substance. Please, is there any question? So 0K is a limiting value of temperature, and that is taken care of on the Kelvin or absolute temperature scale. Class, are we okay? Hello, are we okay?
Sir, please,
Yes,
can you repeat yourself again?
Okay, so what I'm saying is that why this 0K on the Kelvin scale? There is this third point, which is the absolute zero. Okay, on the Kelvin scale, because the temperature of a body can be increased to any, there is no boundary to increasing temperature of a body. Okay, but there is a limit to which we can decrease the temperature of a body. And this limit is the 0K, is the absolute zero. Frank.
So is 0K less than 0 degrees Celsius?
Oh, we'll look at the conversion, so you see it yourself. Okay.
Okay,
0K is far, far less than 0 degrees Celsius. Don't forget, if we are to extend it, then it will be below. When we extend it for the Celsius scale, you realize that this point of 0K will be equivalent to negative 273 degrees Celsius. So 0K is less than 0 degrees Celsius. And we'll look at the conversion. Frank, are you okay? Hello, Frank.
Sir, so how is it possible to record 0K on the thermometer?
No, it's an arbitrary point. It doesn't actually exist on a thermometer. Okay, but it's an arbitrary point. Are you okay?
Yes, sir.
So as I said, is the limit to which we can decrease the temperature of a body. And at this value, molecules have zero kinetic energy, meaning you cannot even record temperature. Saki. Saki.
Sir, please, can you repeat the explanation of the absolute zero?
Mate. So absolute zero. We can increase temperature to whichever value. In increasing temperature, there's no limit. But for decreasing of temperature, there is a limit. So the limiting value to which we can decrease the temperature of molecules is the 0K. Okay, the limiting value to which we can decrease them, and it's limiting because at 0K, molecules have zero kinetic energy. Saki, are you okay?
Yes.
Okay, so let's look at a change in temperature on the Celsius scale, change in temperature on the Kelvin scale, then on the Fahrenheit scale. Very, very important point to understand. So in terms of change in temperature, oh, somebody is reporting of error in connecting. I'm coming. The same details. The same details. Let me forward it to. So a change in temperature. How do we determine a change in temperature on the Celsius and then on the Kelvin scale? So if you take change in, please, the delta symbol represents change in temperature. Subscript C, the C represents on the Celsius scale. Okay. The C represents on the Celsius. I'm coming. Then divided by change in temperature on the K represents Kelvin. So we are looking at change in temperature on the Celsius and on the Kelvin scale. How do we determine this change in temperature? Change in temperature, when you subtract the lower fixed point from the upper fixed point, 100 minus 0 on the Celsius scale divided by the upper fixed point minus the lower fixed point on the Kelvin scale. So 373 minus 273. The numerator would give us 100. The denominator would also give us 100. This ratio is equal to 1. What it means is that for change in temperature on the Celsius and on the Kelvin scale, the ratio is 1:1. Simply, delta TC is equal to delta TK. what this relation actually means is that a change in temperature on a Celsius scale is equal to the same change in temperature on a Kelvin scale. So if we have a change in temperature of 10 degrees Celsius, it is equal to the same change in temperature on the Kelvin scale, which is 10 Kelvin, because the ratio is 1:1. Class, are you okay here?
Yes, yes.
So a change in temperature on the Celsius scale is equal to a change in temperature on the Kelvin scale. The ratio is 1:1. So a change in temperature of 50 degrees Celsius is equal to a change in temperature of 50 Kelvin, and the other way around. Please note this, very, very, very important for changing temperature. It does not, please, this does not mean that 50 degrees Celsius is equal to 50 Kelvin. That's not what I'm saying. Here we are talking about changing temperature on the two scales, delta T. Frank, are you okay?
Sir, can you come again?
So on the Celsius and Kelvin scale, change in temperature for both Tc over delta Tk, this ratio is equal to 1:1, implying that delta Tc is equal to delta Tk. And here the delta implies that we are talking about change in temperature. What do we mean by change in temperature? A body was heated. Its initial temperature is 0, maybe 20 room temperature, 25 degrees Celsius. And it was heated to a final temperature of 50 degrees Celsius. If we want to determine the change in temperature from the initial to the final, please, what is the change in temperature here?
25.
So this is 25 degrees Celsius. This change in temperature on the Kelvin scale is the same as 25 Kelvin. But it does not mean that 25 degrees Celsius is equal to, for change in temperature, they are the same. So we'll later look at how to convert one temperature to the other, okay, using the scales. Are we okay? Frank, are you fine?
Yes, sir.
Let's also look at change in temperature on the Celsius and Fahrenheit scale. So lower fixed point 0, or the ice point 0, and then upper fixed point 100. By this notation or details, what kind of temperature scale is this? By these values, what kind of temperature scale is this?
Yes.
Celsius scale.
Celsius scale. Please let me have the attention of Maurice. Okay, you wanted to answer the question. Okay. Then we have another scale whose ice point we are told is 32. And steam point 212. By these details, what kind of scale is this? Maurice.
There's a Fahrenheit scale.
or degree Fahrenheit. So by changing temperature, what will be the equivalent? So delta T C Celsius divided by delta T K. The numerator will be 100, 100 minus 0. Divided by denominator is 180. 212 minus 32. So this is equal to 5 or 9. It is 5 or 9 when it is Celsius is to Kelvin. It will be 9 on 5 when it is Kelvin is to Celsius. So please note that. Therefore, so this is the ratio for the change in temperature on both, meaning that delta TC, change in temperature on the Celsius scale, would be equal to 5 on 9 delta T. Oh, this is not Kelvin, this is Fahrenheit. Sorry. TF. Class, are we okay? Frank.
So if it's Fahrenheit, wouldn't it be 100 degrees Celsius over 212 degrees Fahrenheit?
Come again.
If it's Fahrenheit, wouldn't it be 100 over 212?
No, it is, I understand what you mean. It's because I jumped, that's why you see it like that. So it is actually 100 minus 0, upper fixed point minus lower fixed point, and then 212 minus 32, which is 100 over 180. And 100 over 180 is the same as 5 over 9. Frank, are you okay here?
Yes, please.
Okay, so this is how to determine the change in temperature. So example, help me do this. What will be the equivalence of a change in temperature of 25 degrees Celsius, okay, on what will be the equivalent change in temperature on a Fahrenheit scale? Yes. We have a change in temperature of 25 degrees Celsius. What will be the equivalent change in temperature on a Fahrenheit scale? Start work whilst I take note of attendance. You are helping me determine the equivalent change on a Fahrenheit scale.
Recording in progress.
Yes, Daniel, have you finished? Daniel,
Hello,
what's your answer?
please. I'm not done.
Hurry up. Anderson,
Yes, sir.
What's your answer? A change in temperature on the Celsius scale against a change in temperature on the Fahrenheit. Okay, Joshua.
Yeah, please, the answer is 5/36.
5 over.
36.
So give me a specific value. A specific value. Anita, what's your answer? Okay, Gideon.
So it's 45 degrees.
Okay, so let's see.
Degree Fahrenheit, yeah, 45 degrees Fahrenheit.
Okay, so what you must know is this: delta TC over delta TF. If you forget this, you can use this, okay, to extract the relation. This is equal to, the ratio is 5:9. 5:9. So it means that since I'm giving change in temperature on the Celsius scale to find the corresponding change on the Fahrenheit scale, I need to make delta F TF the subject. So delta TF then over delta TC will be equal to 9/5. If I reciprocate this side, I must also reciprocate this side, so that delta TF will be equal to 9/5 times delta TC. And what is the change in temperature on the Celsius scale given? That is 25. So 25, this times 25. This 5 goes into 25 5 times. So 9 times 5 is 45 degree Fahrenheit, meaning that a change in temperature of 25 degrees Celsius will be equal to a change in temperature of 45 degrees Fahrenheit. Please, is there any question? So this is, Saki.
Those I don't get it.
Which part?
Okay, so say the change in temperature between Celsius and Kelvin. How I understood it was because the ratio is 1:1. When you cross multiply, you get one, like you get the change in temperature of Celsius is equal to the change in temperature of Kelvin.
Yes.
But here you said the change in temperature of degrees Celsius.
Saki, in this particular change, the ratio is not equal. Okay, for Celsius and Kelvin, when we check the ratio, it is equal to 5:9. This is what we got, 5:9. Here we had 1:1. Joshua, Saki, are you okay?
Yes, sir.
So for Celsius Kelvin, it is 1:1. For Celsius Fahrenheit, it is 5:9. So that is what you must use in determining the change in temperature. Echo, your hand was raised. Okay, Saki.
Joseph, can you say 5 times the change in 5 times the change of Fahrenheit is equal to 9 times the change of Celsius?
Pick it this way, that if it is Celsius over Fahrenheit, It is 5:9. If it is Fahrenheit over Celsius, 9:5. And with this, you can always convert from the one from one to the other. Okay, if you still want to see it as 9 times delta TC is equal to 5 times delta TF, it is also correct, provided you understand what you are doing. Saki, are you okay?
Yes, sir.
So all that we are saying is that if you are given the change in temperature in one, to find the change in temperature in the other, this is what you must use. So another example, let me give you another example.
Sebs, can you go to the previous slide first?
Here we are. The ladies, are we okay?
Yes.
We'll solve another example. And note that this is for change in temperature. We'll later come to the conversion. Can I move on?
Sir.
Okay. So we have a change in temperature of this 103 degree Fahrenheit. What will be its equivalent on what will be the equivalent change on the Celsius scale? Do that for me. 105 degrees Celsius, degree Fahrenheit. What will be its equivalent change on the Celsius scale? Okay, Frank. Okay, Frank, keep it. Okay, we'll discuss it generally, so don't worry. We'll discuss and then you mark, do the marking. Are we all through?
Yes, sir.
Class? Okay, then let's go through it. You will be doing the marking, so. Okay, so using, if I cannot recall the exact formula, on the Celsius scale, ice point is 0 degrees Celsius, steam point is 100. On the Fahrenheit scale, ice point is 32 degrees Fahrenheit. Steam point is 212 degrees Fahrenheit. So using that, delta TF, because I'm looking for, we are to look for TC. So delta TC over delta TF would be equal to 100 minus 0, which is 100, over 212 minus 32, which is 180. This is straight away giving me 5/9. So the change delta TC over delta TF is equal to 5:9. Therefore, delta TC would be equal to 5/9 times delta TF. So what is that change in Fahrenheit given? 103. So 5/9 times 103. And what is this a product and then quotient? 5 times 103 divided by 9. What's the answer?
7.2.
185.5.
So this is the equivalent change in temperature on the Celsius scale. Please mark yourselves. Gideon.
Sir,
Hello.
it's supposed to be 57 points.
Let's please cross check. 5 over 9 times 103.
Yes,
Is that so?
57.2.
57.2.
Yeah, that's what I got.
Frank.
Sir, how can it be lower than how can it be lower if the cell okay, I think I interchange the values. So I got
Okay, so this is it. Can you use the same idea to derive the change in temperature relationship between on the Fahrenheit and the Kelvin scale for me? Use the same idea to get the change in temperature relationship on the Fahrenheit and the Kelvin scale for me. The same thing as we have Frank.
so will it be the same 57.2 since Kelvin is equal to Celsius?
No, I just want the ratio between this in terms of change in temperature. No, we've done it for Celsius and Kelvin, Celsius and Fahrenheit. And I want you to do it for Fahrenheit and Kelvin. That's what I mean.
Okay, sir.
Get the change, the ratio of the change in temperature. Please, do you understand the question? Class, do we understand the question?
Yes, please.
Yes, please.
Okay. All right. I'm waiting. Can we discuss?
Yes, please.
Okay, so let me call somebody to, one lady, one gentleman to help me with what you had. Blessing. Hello, Blessing. Blessing, are you ready? Are you ready to share what you had?
Yes.
Okay.
Sir, please, I had 9/5.
9/5.
Yes.
For change in temperature on the Fahrenheit against change in temperature on the Kelvin, or the other way around.
Change in Fahrenheit over change in Kelvin.
Okay, so that is that 9/5?
Yes.
Okay, we'll look at it. And any different, Gideon?
So please add 12/5.
You had 12.
12/5, yes, sir.
Okay, let's see.
12.
The same TF over TK.
Yes, sir.
That 12/5. And then Frempoma, what did you also get? Frempoma?
He's I got 9/5.
Come again.
9/5.
9/5. Let's see. Let's see how I'll also. So on the Fahrenheit scale, the ice point is 32, steam point 212. Then on the Kelvin scale, the ice point is 273, 373. So change in temperature on the Fahrenheit over change in temperature on the Kelvin, I have 212 minus 32 on 373 minus 273. This is giving us 180. So this is giving 180 divided by 100. Which is actually 9/5. 9/5. Oh, okay. Oh, but it's the same thing with, okay. I get it now. It's the same thing that has been done. So that is it. Now let's look at how to convert from one temperature scale to the other. This is about, note that this is about change in temperature. Okay. Conversion of temperature on the scales. So how do we convert? With regards to conversion, I have my Celsius scale, ice 0.0 degrees Celsius, steam 0.100. Then, so from between Celsius and Fahrenheit, and Kelvin scale first. (273) Kelvin, 373 Kelvin. I have a temperature TC or theta, even theta degrees Celsius. on a Celsius scale, and I want to get its equivalence on a Kelvin scale, TK. How do I do it? Okay, we've done it for change in temperature. This is conversion. So this is how we go about it. Whenever you are looking for, you want to convert from one to the other. The unknown temperature or this given temperature, theta minus the lower fixed point. The concentration is on the Celsius scale. So this minus the lower fixed point, let me write a whole formula. Lower fixed point divided by the upper fixed point minus the lower fixed point. This ratio must be equal to a constant. This ratio must be equal to a constant. So this theta on the Celsius scale minus the lower fixed point, then divided by upper fixed point minus lower fixed point must be equal to a constant value. If I pick another scale, and I do the same thing, this unknown TK minus the lower fixed point divided by upper fixed point minus the lower fixed point, it must be equal to the same constant, no matter the scale. So no matter the scale. So supposing I'm making a constant value of 5 here, this must also give me a constant value of 5, no matter the scale. If these ratios are all equal to a constant value, then I can say that this can be equated to the same thing because they are equal. Class, are you with me? Hello, are you with me?
Yes.
Yes, please.
You don't worry, I will solve real examples. So because they are all equal to constant, then I can say that theta minus its lower fixed point for the first scale divided by the upper fixed point minus the lower fixed point is also equal to the same thing, the ratio for the other scale. So TK minus the lower fixed point on the Kelvin scale divided by the upper fixed point on the Kelvin scale minus the lower fixed point on it. So no matter the scale, this must be constant. So what we are doing is that I'm giving a temperature TC on the Celsius scale. I want to find its equivalence on the Kelvin scale. So what I'm giving TC minus 0 divided by 100 minus 0 must be equal to TK minus 273 divided by 373 minus 273. And when you simplify terms, you have TC over 100 is equal to TK minus 273 also over 100. Okay, 100, when you cross multiply, 100 will cancel 100. So we have TC equal to TK minus 273 or TK is equal to 273 plus TC. This is a conversion equation between the Kelvin and then the Celsius scale. Frank earlier asked the question, if I'm giving 0K, 0 Kelvin, what will be its equivalence on the Celsius scale? So with this, I can determine its equivalence on a Celsius scale. TK is equal to 273 plus TC. What am I giving? I'm giving a temperature on the Kelvin scale, 0. So substitute whatever you are giving for K. I'm giving 0. 0 is equal to 273 plus TC. Make TC the subject. Friend, what's the answer? We are making TC the subject. TC will be equal to
negative 273.
negative 273 degree Celsius. So 0K is equivalent to negative 273. That's all. Can you help me derive an equation to convert from Celsius to Fahrenheit? So we want to create an equation which will help us link temperature on the Celsius scale to temperature on the Fahrenheit scale. Can we try? Can we try? Are some of you also experiencing the light out, power outage situation?
It's like occasional.
I mean,
Even the connection is not even good.
I mean now, as we speak.
No, sir.
Oh,
No, sir,
okay.
but said the connection is the problem.
Yeah.
MTN and the telcos generally. So create an equation to link temperature on a Celsius to Fahrenheit. When you finish, we'll look at it for the other, and then we begin to solve questions. Yeah, I think so. Frank is the telcos. Is this if you don't get a router, a reliable router at home, it wouldn't boost your internet connectivity. Are we through? Lordina. Lordina Bonsu. Oh, she's gone.
Service, I'm here.
How are you?
I'm fine.
Lordina, it's been a while. Oh.
Yes, please.
Okay. We'll discuss that at the flip side.
Okay.
Okay, so let's see. TC against TF. We have Celsius scale here. So let's just clear this and use it for Fahrenheit. The lower fixed point 32, upper fixed point 212. The unknown temperature TF. Okay, please note that it can also be upper fixed point minus lower fixed point divided by, okay, this is mathematics. The order doesn't matter. You need to get the same result. I'll use this to explain better. This is what I'm saying. So once we have this, I can also decide to bring, okay, upper fixed point minus lower fixed point. So 100 minus 0 divided by TC minus 0. Or decide to bring the denominator as a numerator. Both ways must work. Please, are we fine?
Yes, sir.
Yes, sir.
Okay. So this must be equal to, you see the order, you must do same for the other scale. When you change it, it must also change on the other scale. So 212 minus 32 also divided by TF minus 32. If you make the mistake to change it, that here upper first point minus lower first point divided by TC minus 0, and you decide to equate it to TF minus divided, it's wrong. So the order must be consistent. So we have 100 over TC equal to 180 over TF minus 32. When you cross multiply, you have 100 times TF minus 32 is equal to 180 times TC. We can decide to divide through by 100. And this will give us TF minus 32 franc.
Sir, is there a way to convert like the temperatures using the difference in the the changes in the temperatures of the degrees?
They are separate. Change in temperature is different from conversion. Okay, that is why I took you through change in temperature, and I'm taking you through the conversion. Frank, are you okay?
Yes, please.
So TF here would be equal to 9 on 5 times TC plus 32. Well, this is how we can convert temperatures on the Fahrenheit and then Celsius scale. Okay, now, example. What is the equivalent okay, 50 on the Celsius scale, we have a temperature of 50 degrees Celsius. Okay, 50 degrees Celsius. What will be its equivalent on the Fahrenheit scale? Convert it to temperature on the Fahrenheit scale. Yeah, it's start work. You are given a temperature. You are given, okay, a temperature of 50 degrees Celsius.
Thank you, Zaki.
Okay, Elikam.
So it's 122 degrees Fahrenheit.
Okay, let's see. So let's wait for the rest to also work around it. Then we'll discuss it afterwards. Daniel.
122.
122. 122 Ghana cedi.
No, please. Fahrenheit.
Degree Fahrenheit. You see, in physics, our units are very, very important to us. So you don't call without units, okay?
Fahrenheit.
Okay, class, let's see. Let's discuss it. So supposing I cannot recall the equation, what I can also use my knowledge of the ice point, steam point to derive the same. Blessing, where is your sister?
Sir, please, Michaela is here.
Okay. So this is 100. Supposing I cannot recollect that equation I gave you, TC, Celsius. So to the Fahrenheit, so we indicate the steam point 32 degree Fahrenheit, and then 212 degree Fahrenheit, an unknown temperature of TF. So upper fixed point minus lower fixed point, 100 minus 0 over TC minus 0 is equal to the other scale, upper fixed point, 212 minus 32 divided by, what kind of divided by is that? Let me redraw it. Divided by TF minus 32, in case I've forgotten. So 100 over TC is equal to 180 over TF minus 32. cross multiply to eliminate the fractions. So I have 100 by TF minus 32 is equal to 180 by TC. Then divide through by 100. I have TF minus 32 is equal to 9 on 5 times TC. Therefore, TF would be equal to 9 on 5 TC plus 32. I'm to convert from degree Celsius to degree Fahrenheit. So what is my TC given? 50. So 9 over 5 times 50 plus 32. This goes into this one. So I have 90 plus 32. And what is 90 plus 32?
122.
122 degree Fahrenheit. So that's it. Frank, is there any question? Because I'm going to give you other examples to solve. So example 1. The temperature on Celsius scale is 25 degrees Celsius. The temperature on Celsius scale is 25 degrees Celsius. What is the corresponding temperature on the Fahrenheit scale? The temperature on the Celsius scale is 25 degrees Celsius. What is the corresponding temperature on the Fahrenheit scale? This question is for the ladies. The gentlemen, the gentlemen should also take their question. Almost the same strength though. The gentleman, your question is that the temperature of a body on the Kelvin scale. Please, ladies, you can also write this. The temperature of a body on the Kelvin scale is found to be X Kelvin. X Kelvin. When it is measured by Fahrenheit thermometer, it is found to be X degree Fahrenheit as well. So X Kelvin, and when using Fahrenheit thermometer, it is also X degree Fahrenheit. What is the value of X? What is the value of X? I take the question again. The temperature of a body on the Kelvin scale is found to be X Kelvin. When it is measured by a Fahrenheit thermometer, it is found to be X degree Fahrenheit, or the same as X. What then is the value of X? Or what is the value of X? Ella, your hand was up. Ella, speak up. I'm coming. Let me repeat the question. So the question is saying that the temperature of a body on a Kelvin scale is found to be X. Daniel, can you hear me? On a Kelvin scale is found to be X Kelvin. When it is measured by a Fahrenheit thermometer, so the same body, when it is measured by a Fahrenheit thermometer. Gideon, hold on, I'm coming. When it is measured by a Fahrenheit thermometer, it is found to be X. It is found to be X degree Fahrenheit. XX. What then is the value of X? This is a question. Okay, Emma, go ahead. Emanuela. Ella Davis.
Yeah, I'm here.
What the
I was trying to raise my hand to answer the first question that you gave to the ladies.
What's the answer?
77 degrees Fahrenheit.
You had 77 degree. I need a seconder from the ladies. If you got the same value, can you second? Okay, Yasmin, Ashima, more seconders and Tadedes. Okay, I think the answer is 77. Yes. Akushia or Narakumi. Okay, then the second question for the gentleman. Okay, it's for all of you. This is a bit. Hey, Gideon, what's your answer?
500 X is 574.25 degree Kelvin and 574.25 degree Fahrenheit.
You had.
Except is the value for X is 574.25 degrees.
We shall see. So continue trying. We shall see, Gideon. Alcohol. Okay. Okay, blessing.
Sir, please, for the second one, I got 574.25 for the value for X.
Okay, Yasmin.
Yeah, I also got 574.25
In fact, if done well, the answer is 574.25 for X. Thank you. Now, at what temperature is the centigrade and the Fahrenheit readings the same? At what temperature is the centigrade and the Fahrenheit readings the same? That's the next question. At what temperature is the centigrade? Don't forget the centigrade scale is the same as something I made mention of. At what temperature is the centigrade and the Fahrenheit readings the same? Daniel.
Sir, please, can you solve the second example on the board?
Okay. How we managed to get the 570 something. Okay, so the temperature of a body on a Kelvin scale is found to be xk. When it is measured by a Fahrenheit thermometer, it is found to be x degree Fahrenheit. What is the value of? So the contest is between Kelvin and Fahrenheit. Okay. Kelvin and Fahrenheit. So if this is for Kelvin, okay, let me use this and then change Kelvin and Fahrenheit. So this will be 273, this K, whereas this is unknown TK, and this is 373K. So all that I need is a connection between them. So TK minus 273 over 100 is equal to TF minus 32 over 180. So we have TK minus 273 is equal to 100 over 180 TF minus 32. And of course, this will give a 5 on 9. TF minus 32. TK minus 273. Now, on the Celsius scale, the temperature is X. On the Kelvin scale is X Kelvin. Also on the Fahrenheit scale, it's X. So this is X minus 273 is equal to 5 over 9 Also x minus 32. And so for x. So 9 by x minus 273 would also be equal to 5x minus, what is 32 times 5? What is 32 times 5?
160.
This is 160. Then you solve for x. Okay, so we have 9x minus 5x, which is equal to, what is 9 times 273? 9 times 2, 273,
2,457.
2,457 minus 160. And this is giving us 2297. 2297, 4x. When we divide through by 4, divide 2297 by 4. It must give us 574.25. That will be the value of x. So Daniel, that's the solution. Okay.
Yes, sir.
Yes. What about the last question? At what temperature? Yasmin.
About negative 40 degrees Fahrenheit.
Negative 40 degrees. Okay, so that would happen. Gideon.
So is that 33.2 degrees?
Is it, come again?
It is 33.2 degrees.
The answer must be negative 40. How many of you got that? How many of you got negative 40? Anita got it. Yasmin, who else? Clarence, okay, Clarence also. Oh, more hands. Asida, Morris, okay. And Nanakumi, yeah. Okay, let's do it. Let's solve it together. So the question is asking at what temperature on the centigrade scale and the Fahrenheit reading be the same? So the relationship we have between this is that on the Celsius scale, 100 divided by TC, 180 divided by TF minus 32. Okay. So 180 TC is 100 TF minus 32. And this is 5 on 9 TF minus 32. This is equal to TC. So at what temperature will TC be equal to TF? That's the question. So if supposing they are all, the temperature is T or even X. X here, just as the question we just solved, another X. Because we are looking at the point where they will all be equal to the same value, X. So 9x is equal to 5x minus 32 by 5, 160. So 4x is equal to negative 160. X will therefore be equal to minus 160 on 4, which is negative 40 degrees. So x, it must be negative 40 degrees Celsius, negative 40 degrees Fahrenheit. This is the point where they will be the same. Please, are we okay? Hello, are we okay?
Establish here.
Let's look at ungraduated scales. And here we are looking at temperature scales that are not graduated. It's just, you can take this to be a thermometer without any graduation mark. All that we are told is that if the final, maybe we can be given at that maximum temperature, okay, the level to which the mercury must fail, and we can also give us a certain initial. So initial reading of mercury, of the length of mercury reading, and then maybe the question can also give us a final reading. Okay, so at maybe 0, at a temperature of 0 degrees Celsius on a Celsius scale, the reading is this, initial reading. And when it gets to a temperature of 100, it would also be this. So if the level of mercury rises to a certain X, we can be asked to use that length of mercury to determine the corresponding temperature. Okay, so in the case of an ungraduated scale where we are given the initial length of mercury at 0 and at 100, we can also use that to determine the corresponding temperature. So assuming this is on the Celsius scale, and we are asked to find the temperature value which corresponds to this length of mercury at this temperature. Okay, we can use the same idea to find it. So just as we illustrated in, or we saw in the conversion rate, if I take 100 minus 0, upper fixed point minus lower fixed point, divided by the unknown temperature minus the lower fixed point, it must be equal to also the final reading x2 minus initial reading x1. Here the choice is yours as to which letter to use, divided by that given length of mercury minus the initial reading. So we can also use the same idea to find that equivalent temperature. So 100 over Tc is equal to final reading minus initial reading divided by, okay, the given length, or that given length minus the initial reading at 0. Then make whatever I'm looking for the subject. Okay, so in this case, when we turn the left-hand side up, we have TC over 100 also equal to x minus x1 divided by x2 minus x1, and that corresponding temperature TC would be equal to this length ratio times 100 degrees Celsius. And this will give us that corresponding temperature which will go with this length of mercury in the capillary tube. Please, are we okay? Class, are we okay?
Yes, please.
So this is for when we have an ungraduated scale. Note that this is for the Celsius, meaning Celsius ungraduated scale. You can also be given the same thing for other skills as well. I'll send you a couple of examples under this try your hands. Okay, I think I have a question here. Please, I'm reading. A constant volume gas thermometer. A constant volume gas thermometer shows pressure reading. A constant volume gas thermometer shows pressure reading of 50 centimeter, 50 centimeter and 90 centimeter of mercury and 90 centimeter of mercury at 0 degrees Celsius, at 0 degrees Celsius and 100 degrees Celsius. So a constant volume gas thermometer shows pressure reading of 50 centimeter and 90 centimeter of mercury at 0 degrees Celsius and 100 degrees Celsius, respectively. Full stop. When the pressure reading is 60 centimeter, when the pressure reading is 60 centimeter of mercury, what is the equivalent, or instead of equivalent, let's use the corresponding. When the pressure reading is 60 centimeter of mercury, what is the corresponding temperature? When pressure reading is 60 centimeter of mercury, what is the corresponding temperature? So that's the question. We have 2 minutes to end it, so please try it. Let's try. what will be the corresponding temperature when the pressure reading is 60 centimeter? Is somebody true? Class, are you there? Alikem. Alikem, I'm listening.
So please, I had 25 degrees Celsius.
25. Frimpoma.
Please, I also had 25
Clarence.
degrees Celsius.
So please, I had the same here.
Yes, I think that the answer is 25. Okay. So, yes. We are given 0 at 0 degrees Celsius. It goes with a length of 50. 100 is going with 90. So at 60, what is the corresponding? So use this. TC would be equal to X is what we are given, 60 minus X1, 50, divided by X2 is 90 minus 50. This times 100 degrees Celsius. So we have 10 on 40. And the answer is 25 degrees Celsius. Not so difficult. So I'll be sending you a couple of examples for the weekend as weekend challenge. Okay. So class, this is where we end today's session. If you have any question, quickly ask and let's, draw the curtains on our meeting. Is there any question? All right. Absent, silence means no question. So we'll continue next week. Your trial, your weekend assignment will surely follow. In fact, bye-bye to all of you. Take care too.